This is domain number 4, Identity and Access Management. It's 1/5 of the total exam, and you need to understand how to design and implement scalable authorization and authentication systems, as well as troubleshooting the same systems. Well, let's take a look at how to design the authorization and authentication to begin with. To understand this, we need to know that everything in AWS is controlled by an API. Now, you can connect to this through the console, the CLI, the SDK, or other AWS services that connect direct to those APIs, but inevitably, everything is connected by those APIs. So, the request to actually get there is some client, in this case an HTTP client, makes the API request that goes through the API interface, and then it checks identity and access management to see if, in fact, that user, that operator is allowed to execute that API. That action gets written to CloudTrail, whether it's successful or not, and then that final action gets executed through the API endpoint at the very end. How do we secure down our APIs? AWS begins by verifying the identity of every request. We make sure that every request is signed, that there is a valid access key that is presented as part of the API. Every API request has a hash value. It's calculated to decide if any request was modified in transit. This prevents any type of a man-in-the-middle type of attack. We also prevent any replay attacks. All requests have a timestamp, and they must be executed within 5 minutes of the request. Otherwise, even if it looks valid, timestamp is off, we will reject that request. Understand identity and access management and know the moving pieces, where you've got users that have permanent credentials that can be associated in groups. A role is a way to assign temporary authentication methods. It is not permissions by itself. All permissions, whether you're a user, a group, or a role, are managed through the policies that get attached to those other objects. Authentication and authorization as 2 separate processes. Now, looking at policies. Primarily, we have the AWS managed and the customer managed policies. The AWS managed policies are our default, which you can copy and modify if need be in the customer managed. We also have the option for inline policies. Now, these are not as common, but they can be used in specific cases where you want to override behavior at the account level or at the operator level. It's important to understand how AWS evaluates IAM permissions, because it looks at all of the policies associated with an individual, whether it's attached to the individual operator or through their group, before it actually makes a decision, am I going to deny it or allow it? The first evaluation looks at, are there any explicit denies associated with that user? If so, it is a flat deny. Now, if there's no explicit denies, then we look for, have there been any explicit allow statements? If it finds an explicit allow, then it will allow the action. Otherwise, it will be denied by default. Explicit deny first, then the allow statements, then it's not allowed. Now, inside a policy, know your moving pieces. What's the effect? Is this an allow statement or a deny statement? Against what type of action? What are my resources? That's my required set. Now, optionally, I can have conditions that can say it's only an allow or deny if certain elements are in play. I may deny you the right if I'm coming from outside of my system or during particular hours of the day. Also, principles may be in play if I'm talking about resource-based policies or trust-based policies. So here's an example of an access policy. In this case, we're going to allow the operator to get the queue attributes against any SQS function as long as I'm in a certain date time that's in a particular range in 2018, and I'm coming from a particular IP address. Important considerations when looking at IAM. First of all, do not create accounts for users unless you actually need them. Your best option is to make roles and look at federating accounts with your existing identity management systems. Also, avoid using inline policies. Instead, use your customer managed policies as the preferred method. Least privilege is critical. In fact, begin with no access at all and start adding on the basic privileges needed to finish whatever action you want. Don't just give everyone star. And finally, look at ways to reduce the scope of certain policies, such as preventing certain elements using not principal or other pieces to ensure you only have the users and the functions you need and nothing more. When looking at the root user access, it's important to know some of the dangers, some of the do's and don'ts. First of all, you shouldn't be using the root account user in the first place for any type of day-to-day interactions with the AWS platform. There's no way to restrict its permissions, so this should be locked down once you've created the IAM users and given them permissions that are needed. Also, make sure you've got good password management. Never share your root account credentials with anyone. Certainly do not embed them inside your applications or code. Finally, make sure you enable multi-factor authentication on your root user, and then don't use the root access key unless you absolutely have to. Understand how to use the AWS directory service. And there's different levels, whether you're talking about the managed Microsoft Active Directory, which is a case where you actually need to have Active Directory run inside AWS, or you've got your on-premises user, in which case AD Connector becomes the right choice, or simple AD, low scale, low cost, basic capabilities.